Molarity is one way to express concentration. And really, it's the concentration of the solute expressed in moles. Moles of solute. Remember that the solute is what you're dissolving in usually water. The solute in this example is sodium fluoride. Since it has to be expressed in moles, if you have grams, for example, you need to convert your grams to moles using the molar mass. The volume, which usually will be written with an L in the denominator, is the volume of the entire solution, which will usually be nearly the volume of water. However, it's important to note that you need to consider only the volume of the entire solution. So, volume of entire solution, expressed, of course, in liters. In the example here, we have 500 milliliters, which would be 0.5 liters. Let's do an example of how to calculate molarity using this example. If you take 21 grams of sodium fluoride and dissolve it in enough water to create a solution with a total volume of 500 milliliters, then there are a couple of things you need to do to calculate the molarity of the sodium fluoride in this solution. First of all, you need to convert your 21 grams of sodium fluoride to moles of sodium fluoride. If you have 21 grams of sodium fluoride, you need to know the molar mass of sodium fluoride, which is approximately 42. So 42.0 grams is 1 mole of sodium fluoride. Doing the molar conversion gives us a moles amount of 0.5 moles of NaF, which will be our numerator in our molarity equation. 0.50 moles of NaF. Now the denominator needs to be the volume of the whole solution in liters. 500 milliliters, of course, is 0.500 liters, using SOL apostrophe N as an abbreviation for solution. As you can see, 0.50 divided by 0.500 means that our solution's concentration is 1 molar. And that is how you express it. The units for molarity are either just a big M or moles slash liters. And it's kind of neat how your two unit options come directly from the equation. Of course, you will need to sometimes rearrange the molarity equation to solve for either moles or volume. If you have to solve for molarity, you know that you need to either turn grams into moles, or maybe you will be provided moles of solute, and then turn milliliters into liters, or perhaps you'll be provided liters of the total solution. However, if you need to solve for moles of solute, you would use basic algebra to help you solve this problem. So if molarity equals moles over liters, then you can rearrange the equation to solve for moles by multiplying both sides by liters, giving you that the volume in liters times the molarity equals the number of moles. In this example, we can see that we have 1.5 liters of total solution, and 3 molar is the strength or the concentration of the solution. So we're asked how many moles of potassium nitrate are needed to create 1.5 liters of a 3 molar solution. So the volume will be 1.5 liters. The molarity is 3. And when you do the math, you get that you will have 4.5 moles of potassium nitrate. Now suppose you're asked to determine the mass of solute needed to create a certain molarity given volume. You know that you are given the molarity and the volume, so you rearrange using basic algebra, giving you this, which is the volume times the molarity equals the number of moles. We did it already, and we determined that 1.5 liters times 3 as the molarity gives us 4.5 moles of potassium nitrate. Of course, you can just convert moles into grams using the molar mass. We know that 1 mole of potassium nitrate has a molar mass of 101.1. The math works out to give us approximately 454.95 grams of potassium nitrate. Underlining the last significant digit based on our problem, it would really report 450 grams of potassium nitrate. Suppose you have to solve for the volume of a solution. This question asks, what will be the volume of a 0.23 molar aqueous ribose solution with 30 grams of ribose as the solute added to it? So the first thing that I do is I calculate the molar mass of the solute if it is not provided and I have to use it. Notice how I'm given grams or mass of the solute, which is ribose, which means that I need to first calculate the molar mass. The molar mass is approximately 150 grams per mole. Now we look at our molarity equation. Molarity equals the moles of what you're dissolving, which is the ribose, divided by the volume of the solution in liters. I'm going to rearrange this for the volume. If I multiply both sides by liters, I get the liters to cancel on the right, which means L times M equals moles. Now dividing both sides by the molarity, I get the final form of my equation. The volume in liters is equal to the number of moles divided by the molarity. We need to convert the mass of ribose into moles of ribose. 30 grams of C5H10O5 turned into moles. I'm going to use R to abbreviate ribose. Will mean that 1 mole of ribose has a molar mass of 150 grams. 30 divided by 150 is 1 over 5, which is 0.2 moles. The molarity was already given as 0.23 molar. The math, when done, is 0.8696, and with sig figs we would trim that all the way down to 0.87 liters. If asked to determine the volume in milliliters, that would be 870 milliliters of solution.